Okay, let's look at this next problem. So, suppose Aaron is pumping water into a tank in the shape of a right circular cone. Okay, that just means that our tank looks like this. Circular, and here's our cone shape. Okay. At the rate of 1,600 feet cubed per minute. So that's going to be important. It's a rate, and we're talking about related rates. If the altitude, so how high, is 10 feet, so from here to here, it's 10 feet tall, and the radius of the base is 5 feet, find the rate at which the radius is changing when the height of the water is 7. So when we have our water, here's our water, nice and blue, at 7. Okay, not to scale, you know, nobody's perfect. So, and I gave you your equation. So those are the three things: the equation, what is given, and what do we need to find? So our equation we have here 1/3 pi r squared h. We are given dv dt, which is 1,600 feet cubed per minute. We are given the actual height, which I've noted over here, the actual radius, which I've noted over there, and the radius at a time, which I've noted over there. So we need to look at a couple of things here, and we need to find, let's not forget, let's note what we need to find. We need to find dr dt. When we have an equation that has 3 variables, we need to make sure that we have enough information to work with all of them. We have dv dt, which will be there. We have a radius, so they've given us a radius, and we are going to have to figure out a height. We're figuring out dr dt, but nowhere in here do we have anything that helps us find dh dt. That means we need to eliminate h, which means we need h in terms of r. So if we look at our height and our radius, there's something that we can learn about them. So if our radius is 5, when our height is 10, that proportion will be true for any radius and any height that we have. Okay, so we want to solve this and get an h equals so that we don't have a height in our volume equation anymore. So since we have an equals in the middle, what you do is you need to cross multiply. So 5h equals 10r. So we're going to divide by 5 because we need h equals. Remember to get rid of that in our equation. So we have h equals 2r. So that's what goes in place of here. So our volume can be rewritten as 1/3 pi r squared times 2r, which can be rewritten as 2/3 pi r cubed. Now that we have less variables, we've eliminated that variable, we can go ahead and start doing our derivative and plugging things in. The one thing that you need to be careful with is we have we have h, but we don't have r. So we don't know what our radius is of the water at this time. Well, we can use our relation right down here to get that. If h is 2r, and then r, oops, darn computer, let's undo that. Then r is h over 2, so r is 7/2. or if you like, 3.5. You can use either one of those in your calculations. So our r is 3.5. From here, we can take our derivative and plug everything in. So we have dv dt is equal to 3 times 2/3 pi r squared dr dt. So let's plug in and simplify here. We can plug in our dv dt, which is 1600. These 3's can cancel, and we have 2 pi. Our radius is 3.5. And we don't have dr dt because it is in fact what we are looking for. So we will multiply those. 2 times 7.35 is, or 3.5 is 7. So we have 7 pi dr dt equal to 1600. So dr dt is equal to 1600 over 7 pi. And don't forget your measurements. Radius is a line. So remember, radius is just a single line. So when we're talking about radius, we're talking in feet. So the change in our radius is feet per minute. And there is your final answer.